All right, guys, let me actually click record this time. I just went through about 8 slides and did not click record and didn't realize it until I was about 15 minutes in. So, take two. Today we're going to be looking at comparing and ordering decimals. You guys got a chance to see decimals for the first time last week. We looked at, kind of the place value part and then how they're related to fractions, which is some of the stuff we've already known. Did great with that. You're going to see a lot of that for the next week or two. So, I felt pretty good about how we started. So we're going to focus mainly just on decimals today. And I know sometimes in math we'll be doing things and you'll think, when am I ever going to use this? Or, is this something that's actually important to me down the road 10, 15 years? And this honestly is, guys. You've probably already compared and ordered decimals at some point in your life and not even realized it. So when we talked about decimals, we talked a lot about money. So in this example, we got the McDonald's menu right here. We've got a few items, double cheeseburger, Big Mac value meal, all the way down. And you'll notice they've got the prices listed to the right. Now, out in the world, when you read this, you'd probably say, hey, 99 cents, $4.79, $3.80. But we know when we're talking in math, we read it a little bit of a different way. So if I was looking at this double cheeseburger, I would read that as 99 hundredths because there's two numbers after the decimal. The Big Mac value meal will be a little bit different because we've got a number to the left. Now, when we talked about place value, remember, whole numbers go to the left and then parts of a whole go to the right. So the Big Mac value meal would be 4 and 79 hundredths. Chicken nuggets meal, 3 and 80 hundredths. That's because I have 4 whole dollars and then part of a whole, 79 cents of the dollar. Same thing down here. So you've got all your prices listed here. And just to kind of quickly review what we did last week, let me get my marker. When we read this 99 hundredths, we could also write that as 99 hundredths. Or if I'm looking down here at this McFlurry, 1 and 97 hundredths, I've got a whole number and a part of a whole, which would be a mixed number. I could write that as 1 and 97 hundredths. Now, one that we can focus on because we can write it a few different ways. Let's look at that 2 cheeseburger meal, 3 and 70 hundredths. Well, I could write that like this, 3 and 70 hundredths. But I could also show that in tenths because I could take a 0 from my denominator and my numerator. I could show that as 3 and 7 tenths. That would be equivalent. But then I can write that mixed number as a decimal, 3 and 7 tenths. So remember, we can always go from tenths to hundredths. Sometimes we can go from hundredths to tenths. Like this one right here, we wouldn't be able to go from hundredths to tenths here because if I had 4 and 79 hundredths, I could take a 0 from 100. I can't take a 0 from up here. So what we're going to do with this menu is we're now going to take this same list of items and prices, and we're going to look at them in order from least to greatest. So let me go through. So now you've got the ice cream cone at 87 hundredths or 87 cents, listed all the way down to chicken salad, which is $4.80 or 4 and 80 hundredths. Now, this right here, I don't know why I'm just thinking about this. This right here is the reason why I don't eat healthy. Like you can go to McDonald's and you can get 2 cheeseburgers for cheaper than you can go get a salad. That right there is why I'm not healthy. Like you would think, okay, I gotta stop talking about that. So one thing that you want to notice, because you're going to see this in the next couple slides, notice how they're all stacked. Just like when we do addition or subtraction, our place value is always lined up. Notice all the decimals stacked on top of each other. All the numbers in the tenths lined up with each other. All the numbers in the hundredths are lined up with each other. Now, these bigger numbers, these bigger values down here, they have whole numbers to the left of the decimal. These 3 items don't. If I really wanted to, I could put a 0 there, but I don't have to. So that's kind of a preview of what we're going to be doing, taking these decimals and either going, least to greatest, greatest to least, whichever, depends what the question's asking. All right, so here's just a little review of our place value chart. Our decimal would be about right here because to the left, this is where our whole numbers are. I think we talked about this in like September. We went from ones, tens, hundreds, thousands. We stopped at 100,000s. We may have even looked at millions a couple times. but honestly, we're focusing to the right of the decimal right now. We've looked at tenths, hundredths. We're going to toss thousandths in there. And I could keep going to 10,000ths and 100,000ths. We're never going to get there. And honestly, you're not going to see many thousandths either, but in class, we definitely will. So we've got that not only, because I'm going to send this to parents too, we've got this not only on an anchor chart in our wall, your student should have, or your child should have this in their notebook as well. Good resource. All right, so when we're talking about comparing decimals, guys, it's very similar to when we're talking about comparing fractions. Now, when we compare fractions, we cross multiply, but these are the symbols we're using: less than, greater than, equal to. And we compare decimals for the reason we just spoke about. If I can save $1.10 eating at McDonald's by getting something other than something else, I'm most likely going to do that. If I got a little bit of money to spend and I know a Big Mac's cost a little bit more than 2 cheeseburgers, I can do that. So comparing decimals is something that as an adult, geez, I think we use it every day. So comparing decimals to me, though, is a little bit easier than comparing fractions because you're not really cross multiplying. You're just kind of using your eyes. But I think most of you would probably say that comparing fractions is easy, which is just shows that you guys know your facts and you've been getting a lot of practice with it, which is great. So let's take a look at some of these decimals. This gives you some half pipe results from a competition, and it wants us to compare Sarah's score with Danny's score. Good thing is, if you look at all these decimals, they're already lined up. The tenths are lined up, and they have whole numbers too. The ones in the tens place and the decimals are lined up. So that's step number one. If you were going to compare decimals, you've got to line up the decimal points. Okay, so here's Sarah and Danny. Decimals stacked, tenths place stacked, ones and hundreds are stacked. Now it says add zeros if needed. Here, this right here is important. Let me toss a little star on here. Guys, you cannot compare decimals unless they look the same. Meaning, if Sarah had a decimal where there was hundredths and Danny was in tenths, I would not compare them. I would have to make them look the same. So let's just imagine Sarah's wasn't 42 and 1/10. Let's imagine it was 42 and 16 hundredths. Notice now they don't look the same, but guys, I can make them look the same. Because here's what would happen. Most people would see 42 and 42, those line up, but then people would say, hey, 16 is greater than 5. Well, I know for a fact those people didn't make them look the same. Now, this is in tenths. I can always go from tenths to hundredths. All I would have to do to Danny's is add a 0. Now they're both in hundredths. Now I could compare, but then I would look and say, hey, 50 is greater than 16. So if you're comparing these decimals and they're not looking the same, you're more than likely going to get the wrong answer a lot of the time. It just happened. It's just so happened that luckily these already look the same, so we're good. All right, add zeros if needed. We didn't need to. Guys, this part's the easy part, and we've done this when we were comparing just regular numbers, whole numbers. Start at the left, and then find the first place that there's a difference, and that's going to give you the answer. So if I look in the tens place, 4 and 4, those cancel out. I'm going to keep going to the right. The ones place, 2 and 2, those cancel out. All right, now I'm going to move over the decimal to the tenths place. Here's my first difference. If I wanted to know who had the greatest score, I know from looking in the tenths place, Danny had the highest score. If I wanted to know who had the lower score of the two, I know one's less than 5, I would say Sarah. So depending what the question was asking, who scored the greatest or who had the least score, that's how I would do it. I would line up the decimal. I'm going to start on the left, work my way to the right to find the first difference. Do not forget this star because this is going to come in handy in just a second. Only compare decimals if they look the same. All right, so just like equivalent fractions, we have equivalent decimals too. And this kind of goes back to what we were working on Tuesday and Wednesday or whatever days it was. You've got 60 hundredths and you've got 6 tenths. I would be willing to bet money, and maybe even right now as you're watching this, there are people who are looking at this question and say, hey, 60 hundredths is greater than 6 tenths. Well, they already broke the rule that I just told you about. You cannot compare decimals unless they look the same. All right, now, what I would do is follow the steps. Line up your place value. Maybe. All right, the second step was add zeros if needed. I cannot compare these fractions. Okay, can't do it. They don't look the same. Now, I could go a couple different ways here. I could go from tenths to hundredths by adding a 0. Or in this case, I could go from hundredths or tenths. I could take this one and take a 0. I tend to always go from tenths to hundredths. And guys, if I added that 0 in here, those two decimals are very much equivalent. Come on, baby. And then if I showed that on some sort of grid, you would be able to see that an equivalent amount was shaded. Now, that's not the only two ways I could show that. I could also show that as 60 hundredths. I could show that as 6 tenths. So anytime you've got those tenths, you're going to be able to show that 3 different ways. And sometimes if you have hundredths, you can do it as well, just not always. So you've got equivalent decimals just like you've got equivalent fractions. And that's why we kind of looked at all those different ways to write it last week. That was one of your questions on EOG Friday. Did very well. That was great. All right. So here's what I'll say. I'm going to give you a couple chances to do some of these on your own. Like right now, if you're feeling super confident in this and you wanted to go ahead and pause the video and put these in order from least to greatest, go for it. If you're thinking maybe I need to watch a little bit more, totally get it. We'll do it together. But now would be a good time to pause it and try it if you want, and then you can press play and see if you got it. All right, so if I was going to order these decimals, do the first things first, I'm going to line up all the decimals. Now, if you look at the first number, 15, that's just a whole number. It gives you a ones place and a tens place, which means my decimal would be right here if I had one, okay? And it would just be 15 and 0 tenths because it's just 15. All right, then I'm going to line everything else up. 14, 95 hundredths, 15 and 8 tenths, 15 and 1 hundredth, 15 and 1 hundredth, because there's 2 numbers after the decimal. All right, so I've lined up my decimals. I've got my ones, my tens, my tenths all lined up on top of each other. The second step would be to add zeros if needed. Guys, I cannot compare these fractions as they are right now because they don't look the same. So I can either take my hundredths and change them to tenths, or add my zeros and change my tenths to hundredths. Guys, I wouldn't be able to change either of my hundredths to tenths. That's why we always say add zeros if needed. Okay, so now this is in hundredths, and this is in hundredths. Now all I got to do is start on the left side and start working my way to the right to find the difference. So if I look in the tens place, they all have a 1. If I look in the ones place, here's where I find a difference. I got 3 decimals that have a 5, 1 has a 4. Well, the 4 is obviously going to be the least. So 14 and 95 hundredths would be my least. And I can go ahead and cross that out. All right, so I'm at the ones place right now. Haven't noticed the difference. Now I'm going to move across the decimal, and I'm going to look at the tenths place. Well, I know which one's going to be the greatest at this point, but now I got to find which one's going to be the next smallest, because 15 and 0 hundredths has a 0, 15 and 1 hundredth has a 0. So I'm going to kind of ignore this one for a second, then I'm going to move to the next spot. If I look at 15 and 0 hundredths, I have a 0. If I look at 15 and 1 hundredth, I have a 1, which means 15 is going to be my next number. Now, I'm not writing it like I wrote it right here. I'm writing it like it gave it to me. I only added those zeros so I could compare. All right. Now, again, I knew which one was going to be the greatest after looking in the tenths place. But look, both have a 15. Go across the decimal. 15 and 80 hundredths has an 8 in the tenths place. 15 and 1 hundredth has a 0, which means 15 and 0 hundredths would be next. And then that would give me 15 and 8 tenths. Again, I'm writing it how it gave it to me, not how I wrote it. If I wanted least to greatest, I would write it just like that. The thing that worries me the most is I think people would look at these numbers and without making them look the same, maybe say, hey, this is bigger than the other. That's why we add those zeros. So if you compared those and did them just like that, that is awesome. But if you watched and did that one with me, you're gonna have a chance to do some on your own. But again, our steps were maybe we lined up all our decimals, we added our zeros if we needed, which we needed to, and then we went from the left to find the differences to the right. All right. And even though we're doing this today through a video, we're going to get a lot of practice with this on Wednesday when I come back. All right. So here is where, whether you're ready or not, I would really like you to try to pause the video and give some of these a shot. So I'm going to give you some decimals. I'm going to give you some numbers, and I want you to put them in order from greatest to least. So here's where it gets a little different. I've got 35 and 6/100ths. Oops. 35 and 7/10ths. 35 and 5/10ths. Check this one out. Before I read it, look how many numbers are after the decimal. This is 35 and 849 thousandths. So I want you to pause it, give it a shot, and then press play and see if you got it. So we would solve this one the exact same way. Should have room. We're going to line up our decimals. Write them exactly like it gives it to us. All right, got my ones and my tens place to the left, all lined up. I got my decimals stacked. They all have a number in the tenths place. A couple of them have number in the hundredths place. Only one has a number in the thousandths. All I have to do is add my zeros to make these look the same. Okay, this number is now in the thousands. This number is now in the thousands. And y'all, I'm writing with my finger. I'm sorry, my numbers are jacked up. And now this number is in the thousands. Okay, now we just start on the left side, work our way to the right, see which one's the biggest. So in the tens place, they all have threes. In the ones place, they all have fives. Now we go across our decimal, and we're looking for the biggest number. Well, at the top, we got a 0, then a 7, then a 5, then an 8. I have found the greatest number. 35 and 849 thousandths is first. All right, now I'm looking for the next biggest number. I feel good with the left side of the decimal. They're all 35. Okay, back to the tenths place, the first number after the decimal. 35 and 7/10ths, which we have right here is 35 and 700 thousandths, is next because the 7 is the biggest number left. But we're going to write that just like we saw it listed above. 35 and 7/10ths. All right. Once again, I can stay in the tenths place. Top number has a 0 in the tenths. That bottom number has a 5 in the tenths. That's the next biggest number. And I would write that as 35 and 5/10ths, which leaves us with 35 and 6/100ths. For people who just compare those by looking at them without making them look the same, they would probably say that top number is the greatest, but I bet you they would swap these two. They would say, hey, 6 is greater than 5, and they would put those, they would have those switch places when in reality that would be incorrect. So huge benefits to taking those numbers, stacking them, and making them look the same. If you got that right, awesome. Again, lots of practice coming with that this week. So that would it be answered. Why does this thing not work? Oh, there we go. All right. Now, this one's a little bit different. This says order these numbers from least to greatest. Let's see if I got enough room. Again, we got some numbers in the thousands. So this says 0 and, see if you can read this before I read it out loud. 0 and 18 thousandths. See if you can get this one. 0 and 13 thousandths. 0 and 28 hundredths. 0 and 205 thousandths. 0 and 35 thousandths. So my fear would be that they're maybe instantly going to think that this one's the smallest because it only has 2 numbers after the decimal, but we're not going to have that problem because we're going to take them all, stack them up. Hopefully you're pausing and trying these. Oh my gosh, I'm going to run out of room. Okay. Might need to call an audible. Yikes. All right, you guys just have to kind of pretend that I've got everything stacked evenly. My whole numbers are good. Decimals are good. Everyone has a number in the tenths. They all have a number in the hundredths. There is one number that does not have a number in the thousandths. That is 28 hundredths. All I got to do, add that 0 right here. All right, starting on the left side, they all have zeros. I can basically start right here in the tenths place every time. All right, I'm looking for the smallest number. Well, 3 of them have zeros. So I'm going to ignore the 280 thousandths and the 205 thousandths real quick. And I'm going to move to the hundredths place. Okay. The top 2 numbers have a 1 in the hundredths place. Bottom number has a 3. So I can ignore the bottom 3 decimals to start. So the 2 smallest are the 2 at the top. Now I'm going to move over to the thousandths place. Well, the top number has an 8. Second number has a 3. That means that's going to be my smallest number, 0 and 13 thousandths. But then I also know that 0 and 18 thousandths will be my next smallest. Okay. So now I'm back to the bottom 3. I need the smallest of those 3 numbers. I'm going to start in the tenths place. I have 2 of them with a 2. 1 has a 0. Well, I know 0 is the smallest. So my next number would be 0 and 35 thousandths. And now I just got to look at those 2 numbers to find the smallest. Tenths place, they both have 2s. And then in the hundredths place, the top number has an 8. The bottom number has a 0. That is obviously smaller. That would be 0 and 205 thousandths, which leaves us with the greatest number of 0 and 28 hundredths. So just from kind of eyeballing it, this one may appear smaller because you see like a 205 right here. You got to make them look the same. So if I went least to greatest there, it would go from 0 and 13 thousandths to 0 and 28 hundredths. All right, last but not least, this is kind of the comparing. And this is what your homework will look like tonight. If I can just get this thing to work. So I've got, I got 14 hundredths and I've got 41 thousandths. Lazy people are instantly going to say that this fraction, or I'm sorry, this decimal right here is greater because 41 is greater than 14. Guys, they don't look the same. Okay. Same thing down here. They're going to say 760 thousandths is greater than 76 hundredths because it's a bigger number. So pause this right here. Do the same thing we just did. Stack them, line up your decimals, compare them. Okay. If I took that top one, 0 and 14 hundredths, 0 and 41 thousandths. To make them look the same, I'm going to add a 0 here. Start on the left side. Zeros cancel out. When I look right here, 1 is greater than 0, which means 14 hundredths is greater than 41 thousandths. Okay, same thing with the middle. I've got 760 thousandths, 76 hundredths. Add zeros to make them look the same. Okay, they are now both in thousandths, and they are equivalent. Those two would be equal. And then if I took our last comparison, 12 and 23 hundredths, 12 and 79 hundredths. I like this because I don't have to add any zeros. Just start on the left side, work to the right. I see in the tenths place that 7 is greater than 2. 12 and 79 hundredths would be greater. So when I go back to, I'm not going to go back, but if in my mind I go back to one of those very first slides when I said you have to make them look the same, if you do that every time, all you got to do is look at numbers and see which one's bigger. So line them up, make them look the same by adding zeros, and I think you'll crush these. So for your homework tonight, and I think you even have answer choices, I can't remember. It's going to be very similar to this. We'll get more practice with it on Wednesday. We're going to look at some menu stuff once I get back. But other than that, guys, I think that's pretty self-explanatory if you can follow those, those easy steps. And I think on your sheet tonight, it's already got them stacked. So that kind of takes a step away for you. Hope that made sense for you. Keep working hard. I actually might be able to do it right now. I'm going to include a game on the announcement, which I have right here. What I'm going to say is this would need to be played if you have time after you've done your math and your science. But it's pretty cool. I don't like it as much because it's kind of a timed thing, but it's an ordering decimals game. It says to click the numbers in order from least to greatest. So you'll have some balloons floating. Ideally, I would like you to line these up and stack them. But if I'm looking to the left of the decimal, I know 6 is smaller than both of those. Then you would just click them in order from least to greatest. So it would be really hard to line these up in time. But if I'm looking for smaller here, I can kind of eyeball it and know that I'm going in order this way. And I think it just goes until you miss. So fun game. It's more of a speed thing. If you could slow it down, it would be a little bit more fun. But if you have time, might be worth checking out. All right, guys. Hopefully you watch this whole thing. Um, you know,